All right, so today we are finishing up with graphing. All right, we're going to be graphing some more complex ones. That's what that one paper that I handed out. The first one we're going to start with is the one from the problem of the day, because we already found out all that information, okay? So, our amplitude is 1. Our period is 2 pi over 3. We have a phase shift of pi over 6. And which way are we moving? Are we moving that to the left or to the right? We are going to move that to the right. And then we don't have a, and that's it, right? So both of these values affect our x's. Just like before, when it's on the inside, it affects our x's. On the outside, it affects our y's. Okay? So we can do this all in one step, or we can split it up. Which one do you want to do? You want to do all in one, or you want to split it up? Raise your hand if you want to split it up. Okay. So this is how we're going to split it. We're going to adjust the period first, and then we're going to move it. Okay? Because this 3 messes with my period, and then of course that pi over 6, the part that involves the c, moves it left and right. Okay? So we're going to split it. So to do that, we need to take our x values of sine, which are 0, pi over 2, pi, 3 pi over 2, and 2 pi, what I like to call the big 5. And we're going to multiply every single one of these by the reciprocal of b, 1 over b. Okay? Just like you guys did when you did the cosine of 2x and the sine of 1/2 x on your homework. Same thing. Going to multiply all these by 1/3. So when we do that, what's 0 times 1/3? 0. 0. What's pi over 2 times 1/3?
Pi over 6.
Pi times 1/3? What's it? Pi over 3. 3 pi over 6, which is? And then? And one way you can always check yourself if you do decide to split it up this way is that, remember, for regular sine and regular cosine, your period is 2 pi. If you have to adjust your period, your last x value should be the period that you found, which we did, right? Did we find 2 pi over 3 as our period? This last number should always be that number. It's kind of a way to check yourself. And sine, it basically goes 0, 1, 0, -1, and 0, correct? Okay. So now instead of being at here, all the big 5, they basically have gotten squished in. So 0 still is 0. But now I'm at pi over 6, 1. Instead of being at pi, I'm at pi over 3, 0. Instead of being at 3 pi over 2, I'm at pi over 2. And instead of being at 2 pi, I'm at 2 pi over 3. And then, of course, I can keep going with that same pattern and so on and so forth. But this would be the sine of 3x. Does everybody understand that? Does everybody follow that? Is anybody wondering where I got 0, 1, 0, -1, and 0 from? Okay? Those are the corresponding values when you take the sine of 0 degrees. The 0 radian. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is -1. And then the sine of 2 pi is 0. Those are all from your unit circle.
Sine is y, so y coordinate of where those would be at on our circle.
Exactly. Your y's don't change. These are still associated with the big 5. It's just now that since our period has changed, these go with, 0, pi over 3, pi over 6, pi over 3, pi over 2, and 2 pi over 3.
So, okay, so 2 pi over 3 would be,
Then the period.
okay.
So if it was cosine, it would be
If it was cosine, instead of starting at 0, we would start at 1. And it will go 1, 0, -1, 0, 1. now we just have to move it. Our phase shift, pi over 6 to the
Right.
right. So every x is moved over pi over 6. So all you do is you just add pi over 6 to every single one of those new x values. That's how you incorporate your phase shift when you break it up into pieces. Okay? If you were one of those that wanted to do it all in one big swoop, this is what you see on the side, this is what you would end up doing, and then the answers that we're about to get, those will be the ones that you grab first. Okay? So what's 0 plus pi over 6? So this point is now here. What's pi over 6 plus pi over 6? Pi over 3. Okay? What is pi over 3 plus pi over 6? Is everyone following along? Like literally, we're just taking our points and moving them left pi over 6 units. And here's the algebra that's happening to get those values. Okay? What's pi over 2 plus pi over 6? 2 pi over 3. And then what's 2 pi over 3 plus pi over 6? 5 pi over 6? So the graph in the blue is the graph of the function that we were trying to graph from the very beginning. Now you don't have to label those points like I did. I was just doing them so I wasn't writing them down over there on the right side. But that'll be one period. What? Yes.
I'm a little confused with my learning if it's in this matter from so the period if you're going from the midline to the next max, so like the first point to the next point, shouldn't that be 1/4 the distance of the period?
If you're talking about amplitude, are you talking about the amplitude?
No, I'm talking
You're talking about the shifting left and right?
yeah.
Okay. Well, if we look at 0, if we change the period, 0 is going to stay where it is. But to fully shift it with this combination of b negative c over b, it will be pi over 2 divided by 3, which gives us pi over 6. And that's what we're adding to every single x value. And I mean, are you talking about where's in relationship on my graph?
Like if you're going from midline to max, that's 1/4 the distance of the period. So if you go to the next part of the midline, that's 1/2 the distance of the period.
Of the new period. Not of 2 pi, but of the new period. So 2 pi over 3 and 1/4 of that would be 2 pi over 12, which would just be pi over 6. So yes,
But that's
sine.
not the distance that you have between the first point and the max.
Yes. This is only pi over 6.
No, that's 2 pi over 3 is the period of the blue line, correct?
Correct, of the new
So-
function.
1/4 the distance of the period should be the first of the distance between the first point of the blue line and the second point of the blue line. Not the original line.
No, it should be that distance. It should be that distance from that original one to the one on the blue. Not from this point to this point. Yeah. So
That's what they had us doing in comic terms.
What is it? Oh, phase shift.
remember, this can also be written as 1/2 x plus pi over 4. Don't let that throw you off. I hope that wasn't what was throwing you guys off. What's the amplitude? 1, period.
Pi. 4 pi.
Would have been 4 pi. because our b is 1/2, so period would have been 2 pi over b. Keep change flip. And that's where the 4 pi comes from. So it's getting longer, right? Frequency would be what?
5.
It would have been 1 over 4 pi. And then the phase shift, negative pi over 2, because it would have been negative c over the absolute value of b.
So whatever 2 pi? What did you say about?
So it would have been negative pi over 2. Yes. Okay? So that means we're going to be moving to the left, pi over 2 units. Our period is going to be stretched to 4 pi. Our amplitude is still 1, so that doesn't change. And let's graph this. Are we splitting this up into parts? Okay. All right. So my big 5. I'm like, I don't have no space. Every single one of these is going to get multiplied by what number? 2. This is how you change the period. So I'm still going to be at 0. My next one's going to be at what? Pi. Oh, and this is cosine.
Are you multiplying everything by 2 because it says then graph 2 period of the function?
No. We're multiplying this by 2 because since our b was 1/2, we always multiply all of our x's by 1 over b. So that's where the 2 came from. Just like another problem, we multiplied all of them by 1/3 because it was 1 over b.
How does cosine affect this besides the fact that we're taking x values? Are we just graphing x values this time?
Well, with the cosine, we're looking at the x values on our unit circle, and those are going to be the ones. So instead of starting at 0, 0, we're going to start at 1, 0, because that's where cosine starts. It starts at 1. Question?
No,
Okay. Let me go ahead and let me label this. Since I have to do 2 periods, it's probably going to be a little bit bigger. Okay. So 0 will stay where it is. What's pi over 2 times 2? Pi. What's pi times 2? 2 pi. What's 3 pi over 2 times 2? 3 pi. And what's 2 pi times 2? 4 pi. And so I would be continuing the same pattern for another period.
Did you do them in different colors? Oh, I'm sorry.
So not use orange.
Yeah.
So I have to grab 2 cycles here, so I have to, it might be my better answer to keep going. Okay? Since I have 2 cycles here and not just 1. What do you think is going to happen next after 4 pi? It's going to go back to 0 and down to 5 pi. Then what? 6 pi negative 1. And then 7 pi 0. 8 pi 1. It is a periodic function. Repeats the same pattern. And there is the graph of cosine x over 2. The last thing we have to do is shift it left. How many units? Pi over 2, which way? To the left. It's always the opposite of what's on the inside, so it's going to be to the left. Yes.
I need track for
Pi over 2, so I can subtract pi over 2 from every single one of these values. The new values that you got after you multiplied by 2. Okay? So, this is negative pi. This point at 0, 1 is going to be shifted over to what value? Positive or negative? Negative. pi over 2, 1. This point is no longer going to be at pi 0, it's going to be where? Pi over 2, 0. Every point is getting shifted over pi over 2, and these would be the same values you would get if you were to subtract pi over 2 from every single one of these. I don't have the space to show that. If I did, I probably would. Okay? Pi over 2, if I subtract, 2 pi, if I subtract pi over 2 from that, what would I have?
3 pi over
3 pi over 2. So this point is moved over that way. And the same pattern continues all the way through. What's halfway in between 2 pi and 3 pi?
2. 5. Shoot. 5.
5 pi over 2.
Yeah.
This point, you shift it over halfway. What's halfway in between 3 pi and 4 pi?
Oh, it's on
7 pi over 2. You see, you notice something? Notice the pattern?
Oh, it's all out 2.
Shift it over here. This point will be here. What's halfway between 4 pi and 5 pi?
9 pi over
I skipped one?
Yeah, because like you see the pie, and there's not a okay. You're fine. Okay, I didn't see it.
Sorry.
You shift it over. Okay.
Shift it over. This one is now here. What's that point? What's that? 11 pi over 2, and it just continues. Shift it over. 13 pi over 2. And then the last one, 15 pi over 2. Okay? So if you connect all of these, that black line is the graph of cosine x over 2 plus pi over 4. Find amplitude, period, all that good stuff. Graph it. Amplitude, period, phase shift,
Oh, why is it a negative?
because it's negative c over b. So since it's already a negative, it's negative and positive. Frequency, forgot that. Let's go and do some pieces.
I mean, so this is a video, right?
Yeah.
So it would probably be helpful to just do this one all at once. So people can see how to do it.
That's true.
Yeah.
It is true. Okay, let me show you all at once. Okay. I'm telling you, it's actually kind of nice because you do all the math first and then you just plot the final thing. Okay, so here we go. So you have, it's for me, it's so much to keep up with if you do it in pieces. And if you make a mistake in one spot, it's going to hurt. And you look at it, it's like, oh my gosh, it's a big mess. Okay, so we're going to multiply all of my x's by, very good. Okay, so on the 1/2 part? Okay,
You do it the reciprocal of the integer, right? I mean, not the reciprocal of the b.
Yeah, don't you feel like
One
Yeah.
over b.
it's 1 over b. So whenever there's a b, you always multiply your x values by 1 over b. Okay, because that deals with your horizontal stretching and compressing. And remember, it's always the reciprocal of the number on the inside. So if it's a whole number, you always flip it and make it a fraction, and vice versa. Okay, so that's why for this one,
so if it were to be 1/2, we would multiply times 2.
right? So that's why we multiply it here. This one was by 1/3. This one was by 2 because it was 1/2, and that's why this one is going by 1/2. So this will be 0, pi over 4, pi over 2, 3 pi over 4, and pi. Everybody still with me?
Yeah.
Okay. Now, We also have a phase shift that you guys got to be pi over 6, which is correct. We are going to add pi over 6 to every single one of these. Okay? So 0 plus pi over 6 is pi over 6. Pi over 4 plus pi over 6 is 5 pi over 12. Pi over 2 plus pi over 6 is
2 pi over
2 pi over 3. 3 pi over 4 plus pi over 6 is
11 pi over 12.
11 pi over 12. Come on. And then pi plus pi over 6 is 7 pi over 6. Those values in that last column are the x's of your final graph.
So, since this is a sine, so the x-axis is the y's in this case.
Mm-hmm.
But in the cosine, the x-axis would be the x.
2 minutes.
Okay.
Now, I do have an amplitude compared to the other ones. Amplitude affects your y's. So every single one of your y's of your original sine function, which were 0, 1, 0, negative 1, and 0, all are going to get multiplied by what number? 3. This one stays true to its actual number. So I have 0, 3, 0, negative 3, and 0. Once you've done all that algebra, now all you have to do is graph everything you just found. Okay? So if pi over 6 and 0 go together. So if pi over
Attention teachers, it's time for our afternoon announcement. Just a reminder, students participating in
yes, the blues are your y's and the reds are your x's that you would graph along your curve. That's exactly the same thing you're doing in pieces if you were doing the other way. Okay? So if you do it the way of doing it all in one and only graphing your final your final result, basically the values that you find in the red, which are your x's, match up with the values that you find in your blue, which are your y's. So pi over 6 would go with 0, as you see right there. Then 5 pi over 12 would go with 3, which you see right there. 2 pi over 3 would go with 0. 11 pi over 12 would go with the negative 3, and 11 pi over 12 is located right before pi. Okay, so it's a guess. It's about right there. And then 7 pi over 6 would go with 0, and we know 7 pi over 6 was right after pi. And so then if I were to connect all of them, this is what I would have. And I would continue this pattern until I got to 2 full cycles, okay? But it's the same thing that you would get if you were to break it up into pieces, like multiply by pi, multiply by 1/2, graph all of those, add pi over 6, graph all of those, and then stretch it by 3. And honestly, that might be a little bit too much to do all in one graph. But by doing this, you'll actually get the points, and you can actually label them nice and neat, and just have the one graph instead of multiple graphs on the one. It's a lot of algebra, it's a lot of mental math type stuff, but that's probably the hardest part of it, not the actual graphing itself. Okay, so for your homework, you're doing numbers 1, 2, 3, and 4 on the worksheet handed out.